All right, the final part of step 17 is all about cube root functions. They're very similar to the square root functions, however, their shape is going to be different. And one thing to remember is that when you're taking an odd index root of a number, it's okay for that number to be negative. When the index is even, like square root or fourth root or sixth root, what's under the radical must be positive. So here we don't have to worry about that anymore. Again, in our key concept chart here, we have a lot of abstract words here. If k is positive, it's k units up. Sometimes speaking with variables is very hard to grasp. So again, I prefer to look at an example with numbers actually, and then go back and refer to that key concept chart. The chart's nice. It has everything you need to know in it. It's just hard to just read it and know what it means. All right, in our first example, it's very similar to what we were doing in the last video. Subtracting a number outside the radical is still going to cause that vertical shift down 4. And this addition of 3 under the radical, that's going to still cause a horizontal shift. Remember, it's the opposite of what it looks like. That's going to go left 3. That's all that's happening here. Let's go ahead and graph this. Now, if we try to graph it in Desmos again, notice there is no cube root. There's a square root, but there's no cube root. But if you recall from another video earlier, we can type a cube root simply by using rational exponents. So instead of the cube root of x plus 3, I'm going to type x plus 3, and then I'm going to do shift 6 to make an exponent, or I could have used this button down here, and I'm going to type 1/3. That makes it cube root. And then the part outside the cube root is subtract 4. So I'm going to push subtract 4. Now, if you find Desmos and having to convert to the rational exponents challenging, the next example I'm going to use our TI-84 graphing calculator, just so that you have different options at all times. Again, if you pull up your table by pressing this gear, press table, you'll see a lot of nice numbers that we can plot. Actually, not too many nice numbers, because I don't want to plot any of these long decimals. But -2, -3 is a good one. So I'm going to get that on my graph before I forget about it. -2, -3. That's 1 point. Just looking at the graph, it looks like there'd be another point here around -3. So let's try that. -3, sure enough, -3, -4. So I'm going to put that on my graph. -3, -4. And I'm going to try -4. Sure enough, -4, -5 is another nice point. All right, what other nice integer coordinates would we have? Maybe around 5. I wonder if that's a good point. 5, -2. Sure enough, that's a nice point to plot. 1, 2, 3, 4, 5, -2. And going back, we just want to get as many points on our graph as possible. Looks like maybe -10 would be a nice one. Not totally. I mean, it's pretty close to -6. -10, -6, but trying to find integer coordinates would be best if we can, but I don't know if we're going to find any other integer coordinates right now at a glance. So let's stick with what we have here. We know that it comes up, goes through this point, and continues on. It comes down here and continues on this way. So we've graphed up our cube root function. Now let's talk about some of the key characteristics. Let's talk about the domain. Notice if I look at my graph, I'm looking at my x values from left to right. As I go from left to right, no matter where I am, there is graph below me everywhere I go. So we can say all real numbers. Other times you might just put this symbol. That symbol, the R with 2 lines, means the same thing. Now we need to think about the range. For the range, we're looking along the y-axis. Where is their graph? To the left and right, you know? Well, initially you might say it's from about here to about here, because that's where my graph is. But you need to also think, we haven't graphed the entire function. The function continues to go on and on and on, and it just keeps going up, 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 up. And similarly over here, it just keeps getting lower. It's very gradual, but it's getting lower and lower and lower. So this graph would actually be all real numbers for the range as well. One thing I want to point out, to write that with interval notation, you just simply say negative infinity to positive infinity. Let's talk about the end behavior. Let's look to the left. As my graph is going to the left, as x approaches negative infinity, as I'm going to the left, y approaches negative infinity. My graph is going down. As I go left, my graph goes down. As x goes to the right, or to the positive side of infinity, my graph is going up. It's gradual, but it's going up. And the last thing of any value is our point of inflection here. It's kind of the turning point in our graph, and it's right here. That's our point of inflection, or POI. And that is the point -3, -4. The point of inflection will always be the HK value, where this is my H and this is my K. Okay, let's talk a little bit about this next one. Again, we have lots happening. We're adding a number outside, we're subtracting a number inside, we've got a negative out front, we have a 2 as a coefficient. This is going to cause a reflection over the x-axis. It's going to cause a vertical stretch. Now, if this number here is a fraction between 0 and 1, that's going to be a vertical compression. It kind of flattens it out. This number makes us go horizontal shift right 1. This tells us it's a vertical shift up 3. All right, and as promised, let's put this one in our graphing calculator. -2 times the cube root of x minus 1 plus 3. I'm going to press y equals. -2 cube root is found under math, option 4. Cube root of x, I want to make sure I type it correctly, minus 1 plus 3. Minus 1, then I press the right arrow to get out of the radical, plus 3. What you type here must look exactly like what is on your paper or the given problem. When I press graph, I get an error, so I'm going to say go to. Oops, you know what I did wrong? I think I typed negative instead of a minus. It happens. Let me put that negative symbol in instead. All right, let's try graph. There it goes. There's our graph. Now, just like Desmos, we can see a table of values so that we can pick some nice points with integer coordinates to put on our graph in OneNote. To get there, I want the table, so I'm going to press second, graph, and I have some nice points to start off. 0, 5, 1, 3, 2, 1, 0, 5, 1, 3, 2, 1. What other nice points do we have here? Here's 9, negative 1. That has integer coordinates. 2, 4, 6, 8, 9, negative 1. Now to get other points, I just need to use my cursor to go up. See if we can find any points. Oh, negative 7, 7. That's a nice point. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. That might be as many nice integer points that I can fit on my graph. Let's see. Do you have any other nice ones? I'm not coming upon many. And I've already fallen off my graph if I go to numbers that high. But you get the idea. So we find as many nice points as we can. And from here, we just need to connect our points as neatly as possible with an arrow on the end. All right. Our domain is going to be negative infinity to positive infinity. Our range is negative infinity to positive infinity. Our end behavior as x goes to the right to positive infinity, I'm going down. Y is approaching negative infinity. As x goes to the left, as I move along the graph towards negative infinity, I'm getting higher and higher and higher on y. Y is approaching positive infinity. And my point of inflection is going to be the point 1, 3.